regarde la salle, je vois que la réaction est positive, je n'entends pas d'objection. L'accord de Paris pour le climat est accepté.
Okay, after about 3 years of study, research, development and construction, the climatic chamber, which will allow to simulate the Earth conditions, is ready and today arrived at Finland. We have now 2 rooms dedicated to the facility that will be used to host the huge apparatus and the accessories. This chamber was made thanks to the support of several factories and firms well specialized into this special machining and construction, because it requires expertise in terms of vacuum and heat control, wind fluxes, etc. So from today we are ready to start to assemble this incredible new facility. I think that we are going to have the opportunity for new projects, and what we really would like to do is to push metrology outside our laboratories, as you're also used to do, I think.
Absolutely. I mean, our group has spent a lot of time trying to take some of the laboratory work and take it out into the environment and make sure that what's done in the laboratory is actually useful in the real world, the outside world.
That's challenging.
It is the biggest challenge that metrology faces, but it's also the biggest opportunity.
We are in Nashe today, and the chamber was transported by the helicopter in Saint-Bochet, where there is a small airport, but it cannot go further due to the weather conditions. Today we're going to take the chamber, dismantle the boxes, and bring the chamber to the portals. Okay, finally we arrived. We are at the pyramid. You can see it behind us. And the chamber was perfectly transported by our Sherpa porters. And everything is here. The stuff is here. The breath is hard. We are at high altitude, but for sure the next day we will try to set up all the system in order to leave the local staff of the pyramid in a condition to operate practically the calibration of the instruments that they are working around here.
Number one is
Number one.
white.
White one?
Yeah.
Okay,
Number
good.
two, blue.
Blue.
Okay, three.
Choose this place because it's in the center, it's in the heart of the structure, and can guarantee real stable conditions, which is absolutely needed for temperature meteorology and pressure meteorology equipment. So here we have set up the instrument that were previously tested and developed at INRIM. This chamber was completely designed and manufactured at INRIM, in the Metrology Institute, and allows the calibration of pressure and temperature sensor, and the humidity sensor can be calibrated by comparison, and it can be improved, and this will be the continuity of the project, also for not only for air temperatures sensor, but also for ice, water, and soil sensors. It allows the change and control change of the quantities independently one to the other, and this allows also to check or evaluate the mutual influences between the several quantities. This apparatus was tested, as we said, at INRIM, but not at this challenging condition that we have at this altitude. So we have to recall that we are at 5,000 meters, and all the instruments have to be carefully controlled, checked, and set up. The machine now is working. In those 2 days, we've been able to put this very small laboratory in operative condition, and we also trained the local staff for allowing them to start to operate by their own and guarantee the calibration procedure that we suggested and the traceability through the standard instrument that we will constantly recalibrate through the national standard, via the national standard at our institute. This way, the traceability is really brought at high altitude.
We are now inside the VK2CNR pyramid in Lobuce. We are in the server room. In this room we are receiving in telemetry the data from our station, the remote stations, and the station closest to the lab, even by Wi-Fi and optical fibers. These data are from here then forwarded to the Italian servers, and a good part of this data is available in real time or in nearly real time. For us it is important to provide information as soon as these are available. This makes us really interested and makes us feeling the need of maximum accuracy even before a validation of the data, to provide valuable information as much soon as possible.
And giving traceability to the measurement makes them really robust, and also the people working in the field, I feel that they are more comfortable if they are somehow dressed into evaluation. They really like their measurement more when they understand
the uncertainty
which are the key problems
and the use that they have for them. And you have these research groups all over the world, but as soon as you have traceability, all these groups can link up and you can be part of one global activity rather than working independently and compare between the groups.
That's right.
And understand what's happening in one country is similar or different to other countries, and that's really what metrology brings. It's that ability to link countries together and have all the measurements contributing to a one global effort.
The research is an approach, an example of a meteorological approach applied to agriculture and food science field. In particular, we are monitoring the variability of the tomato grow in a particular greenhouses that are covered with different covering materials, able to filter or not a specific length. We have a thermohygrometer for the temperature and the relative humidity of the air, the UV radiation sensor, and solar radiation as a pair, such as a photosynthetic active radiation. In this period, we are also evaluating the lifetime of the film covering the greenhouses with a traceable instrument and calibrated instrument. The main aims of the research is to evaluate how the measurement done in these different covering materials can be a part of the budget of a component of the measurement uncertainties, can be resolved in a different percentage of productivity of the crop.
We are in the Bessonese glacial basin in northwestern Italian Alps at an elevation of about 2,700 meters. And in the framework of the RISC project, we are studying the relationship between climate and geomorphological processes.
Knowing temperature condition of the rocks is very important in order to know thermal conditions of the rock falls on occasion of rock falls and debris falls, especially in areas like these ones, in periglacial areas where permafrost is present and all the cryosphere conditions heavily the occurrence of sloping stabilities.
The sensors we are going to install in the Bessonese glacier area are these ones. They're called microtem, and they are sensors with their own data logger. They are reliable, they are fast, they are waterproof, so that we can also install them into streams of water. And in the framework of MeteoMet project and consortium, we calibrated them at our laboratories. In this manner, we achieve an accuracy of measurement inside rocks and in river streams, which can very well detect trends we are looking for, which are very tiny and need accurate measurements.
The cryosphere plays a key role in the stability processes, especially in the high Alps and in remote areas, where still some remains of glaciers are present, like the one that we have here, which is the Bessonese glacier. Of course, temperature becomes fundamental when we need to detect the status of the cryosphere and how much the ice is melting, both the ice inside the glaciers as well as the ice in the underground.
These very long-term measurements, like this one, which is extending back to 18th century, they are highly valuable for understanding what has been this natural climate variability. These measurements are highly important. They are the backbone of both weather forecasting and they are also the backbone of climate science, atmospheric sciences. And it's highly important that we ensure the long-term sustainability of these measurements.
The Moncalieri Observatory, outside Turin, Italy, has a long and uninterrupted record of measurements. Moncalieri was established in 1859. Luca Mercalli is the president of the Italian Meteorological Society.
In questo osservatorio Francesco Denza fondò la Società Meteorologica Italiana e guidò la nascita della prima rete nazionale di stazioni meteorologiche dalle Alpi alla Sicilia. Alcuni strumenti non sono più in servizio, ma raccontano la storia della meteorologia. Questa è la capannina meteorologica di Stevenson. Qui sono ospitati i sensori di temperatura e umidità che operano nelle stesse condizioni di oltre un secolo fa, per mantenere la confrontabilità della serie storica. Sono regolarmente tarati con l'Istituto Nazionale di Metrologia e il progetto MeteoMet.
Here in Moncalieri we have an historical series lasting since 1866 with no any interruption. So we have a continuous recording of data, of course changed during the years thanks to the modern technologies and methods of observation. And the temperature is recorded since then. Together with the historical thermometers, we are now recording the temperature values with modern sensors. And here we have the new generation of instruments that they continue the historical series here in Moncalieri. First thermometers were installed in the late 90s and were calibrated directly by the MeteoMet project, coming here inside with a transportable chamber. The new generation, these two new instruments, they were just installed here. They are one aspirated, forced aspirated and naturally ventilated screen with thermometers inside, and they were calibrated by a company who provided the instruments and was sort of trained by the MeteoMet project, being a collaborator. In this way the historical series continues the data from the couple of centuries ago and is perfectly linked, more robust, being made of parallel observation and fully documented in its traceability to the national standards. Arctic Circle Conference and Assembly offer a unique opportunity to meteorologists to get in contact directly with this very big and most important event for the Arctic science. It is the first time that the breakout session organized this time by MeteoMet is specifically directed to meteorology and the quality of measurement. People is really interested now, after so many experiments are running, to improve especially the quality of measurement. The meteorologists and the people that gathered and took part and presented their experience in this breakout session were of a really high level, coming from the main Meteorology Institute of Europe.
Metrology, and in particular this particular event, is an excellent opportunity to show that metrology and MeteoMet is really addressing grand challenges: environment, health and energy. And MeteoMet is an excellent example of these activities.
Seminar on Metrology is a perfect conclusion of an excellent edition of Arctic Circle 2015, which was about international cooperation, data collection, data reliability. Exactly the essence of metrology and of a wonderful endeavor you are performing.
A lot of things is happening around the Arctic nowadays, and to be able to make the right decisions, metrology is fundamental. So I believe a lot of new measurements and traceable, accurate measurements will be necessary. In our case, we work in remote sensing, and I think it's a lot of things we will be able to do that will be very, very useful for the Arctic community.
Did we ever met? Yes. We met officially. These are our two bosses meeting in 2010 when we had a really historical event in Switzerland, and when the WMO set, let's say, a piece of history, because if you give a look at the countries that signed the Convention on the Met, that it means to agree on the traceability to a unique SI system of units, we have 4 institutions, and one of these institutions is WMO. So the story started, and from the metrology side, I mean BIPM, the place where the kilogram is kept, we started to organize and set up new groups, task groups on metrology, and start to deliver documents to the institutes of metrology. So each nation has its own Institute of Meteorology, and this recommendation passed by the CIPM, the committee that says what the meteorology must do.
The first thing I want to tell you is that the definition of the Kelvin and the degree Celsius are going to change next year. The second thing I want to tell you is that the International Temperature Scale of 1990 that you all use to calibrate your thermometers is slightly wrong. Oh my God! But I would also like to... we're going to talk about this one first, but I would like to tell you that neither of these changes will significantly affect meteorology. But you should understand that they're going to happen, because what they describe is the foundations on which you're building your science. Why I told you that? Many people wonder that. They come to my laboratory and they're unable to hide their indifference. So I created this slide. I said, just pretend that I told you that what I was doing was polishing a piece of glass to make a lens. I wouldn't even need to explain to you why I was doing it. It would enable people to see things more clearly without any distortion or blurring. And that is what precision measurement does. Precision measurement literally brings the physical world into sharp focus. And that's what I've been doing. Thank you very much.
And at the end, if we do that effort, this is really for improving quality of the products and services we can deliver based on method of observation. So let me, from this mission, give a few congratulations on the latest development over the last, let's say, years to months. And I would like to give special greetings and thanks to the whole solid precipitation intercomparison experiment participants, the test sites, the manufacturers. This is one of the major contributions over the last few months. As Andrea Merlone, yesterday you had your highlight with the Metrology for Meteorology. And this is really a great opportunity. And yesterday morning I had the chance to be there. And I can only say that we are taking off together. And that is a wonderful thing, really. Congratulations, Andrea. Brian?
Welcome to all of you. Thanks for coming. And thanks for joining this second MMC. It was really a pleasure to be hosted here in Madrid. It's a great exhibition and TICO conference. So again, thanks for coming and for your interest in this, let's say, sort of new field of metrology for meteorology.
It's a real pleasure for me to be here today addressing MMC 2016 on behalf of WMO's Instruments and Methods of Observation program, and thanks Andrea for the opportunity. We saw that as a really good opportunity to get the meteorological community working directly with us to tackle some of the more challenging problems that we face in meteorological measurement. So we thought that by bringing the two communities together to address the issues, we were more likely to make significant progress than could be achieved by either community working on its own. The kick-off meeting in Torino, which I remember very well, I was amazed at the breadth and the ambitiousness of the plans for MeteoMet, but I must say I was a bit dubious about, you saw me writing those names, can they really achieve this stuff? I thought some of the tasks were a bit too difficult, and I also wondered how well the meteorological community understood measurement, the difficulties of doing measurements or traceability measurements in the field. It's one thing to have very nicely traceable and very tight uncertainties associated with measurements in the laboratory, but to go out there in the middle of the paddock, in the middle of winter, inside the Arctic Circle, or 5,000 metres up a mountain, as the case may be, that presents unique challenges. And I thought, well, I think you guys are in for a bit of a shock. But okay, it proved me wrong, well and truly. I think it was incredibly successful. It convinced me that this was a good idea. I think Bertrand Calpini, the president of CIMO, is similarly impressed with the progress that's been made under MeteoMet. And I, in particular, am a very strong supporter.
buono, non c'è neve e siamo interrotti da
Guarda se è ben orizzontale.
Mi ridici il nome del suo paese?
Perché mi sembra leggermente.
Per iniziare a essere indipendenti nel garantire riferibilità attraverso le tarature degli strumenti.
The series started in 1865 and of course changed all along the years, but it is still uninterrupted, porco. Scusate, la rifacciamo.
Not the problem.